Hello everyone. In today's session, we see the concept of sparse matrices. A matrix contains m rows and n columns of elements as illustrated in the figure. In the figure, the elements are numbers. The first matrix has 5 rows and 3 columns, and the second has a 6 rows and 6 columns. We write m into n, that is m by n, to designate a matrix with m rows and n columns. The total number of elements in such matrix is mn. If m equals n, the matrix is square. We write m by n to designate matrix with the m rows and n columns. This is a figure. We have these matrices. I can see there. This is a matrix, and here we have another matrix, so which consists of all more number of zeros. So that is why we call it as a sparse matrix. What is sparse matrix? A matrix which contains many zero entries or a few non-zero entries is called as a sparse matrix. The figure B contains 8 of 3 elements are non-zero, and that is sparse. Important note, a sparse matrix can be represented in 1 dimension, 2 dimension and 3 dimensional array. When a sparse matrix is represented as a 2 dimensional array as shown in the figure B, more space is wasted. Example, consider space requirement necessary to store a 1000 into 1000 matrix, that is only 2000 non-zero elements. The corresponding two-dimensional array requires space for these many elements, 10 lakh elements. The better choice is by a representation in which only non-zero elements are stored. Sparse matrix representation. An element with a matrix can be characterized by using a triple row column value. Means that an array of triples is used to represent a sparse matrix. Organize a triple so that row indices are ascending order. The operation should terminate, so we must know number of rows and number of columns and the number of non-zero elements in the matrix. Implementation of the create operation. So sparse matrix create max row comma max column. So here we have a maximum terms it is 101. So we are using typed abstract. So we have a 3 members column row value. And then it is a structure variable. It is term. So we are creating a structure variable or array data structure variable. So here it is a of max term. Then the below figure shows a representation of matrix in the array. A of 0 dot row contains a number of rows. A of 0 column contains a number of columns. And A of 0 dot value contains a total number of non-zero entries. So this is what the figure shows with a sparse matrix stored in a triples, row, column and value, and its transpose matrix. Transposing a matrix. To transpose a matrix, interchange the rows and columns. This means that each element A of ij in the original matrix becomes element A of ji in the transpose matrix. A good algorithm for transposing a matrix, for each row I take element ij value and store it as element ji value of the transpose. If we process the original matrix by row indices, it is difficult to know exactly where to place element ji value in the transpose matrix until we processed all the elements that precede it. This can be avoided using the column indices to determine the placement of element in the transpose matrix. So for all elements in column J, place the element I, j value in element j, I. So transpose of term A and term B. So here we have A of dot 0, B of 0 which is equals to A of column. That means we are storing a column value into row and row value into column. So this is what we have implemented using the C language.